Namaste students. Now ಇವತ್ತು moment of inertia of a thin rod the derivation ಕಲ್ತ್ಕೊಳ್ಳೋಣ. So ನಮಸ್ತೆ. So here AB is a rod. So a thin rod uniform rod ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀವಿ. So rotational axis ಬಂದ್ಬಿಟ್ಟು center of the rod along its half of its length ಇಂದ pass ಆಗ್ತಾ ಇದೆ. So CD is here. You can observe or you can see here CD is the rotational axis for the thin uniform rod. And the left side it is having a length as L by 2 and right side is also the same length it is having of L by 2. Right? And here I am considering a small element dx and it is the distance at the position of x from the rotational axis. Come. So linear density of the rod is m by L. We know that the linear density is equals to mass per unit length m by L. Similarly, so here I'll consider the linear density for the element. So that is nothing but the linear density for the element is. Now linear density for the element is rho dash is equals to m by dx. So therefore equate the two densities, that is m by L is equals to m by dx is equals to small m is equals to m by L into dx. By definition of moment of inertia, I equal to m into r square. So m is the mass of the element, that is substituted as m by L into dx and x square as it is. So now I is equals to here integration L minus L by 2 to L by 2 m by L into x square dx. So after integrating this, we will get as x square dx, integration of x square dx is x cube by 3. So minus L by 2 to plus L by 2. Substitute the upper and lower limits in this. After substituting the plus L by 2 and minus L by 2, we will get m by L is into 1 by 3 minus L by 2 whole cube minus into minus L by 2 whole cube. So after substituting and simplifying the equation, we will get m by L into 1 by 3. So cancel the terms which are cancelling. 2 1s are 2 4s are 8. So we will get ml square by 12.